So the basic manipulations in square roots, we can take square root of AB, and this is square root of A times square root of B, and we're going to assume that A and B are both non-negative. As a special case, A equals B implies that the square root of A squared is equal to A. Again, everything is non-negative here. For example, the square root of 8 minus square root of 32 is the square root of 8 minus square root of 4 times 8. And that's the square root of 8 minus square root of 4 times square root of 8. And that's the square root of 8 minus 2 root 8, which is minus root 8. But root 8 itself is the square root of 4 times 2. And similarly, that's root 4 root 2, and that's 2 root 2. So this thing becomes minus 2 root 2. If you like, you can also expand as another example. 7 minus 3 root 2 squared is equal to, if we remember that in the general case, a plus b squared is a squared plus 2ab plus b squared, this becomes, this is 49 is 7 squared, 42 is 2 times 3 times 7, and this is, the last part is minus 3 root 2 all squared, and that bit is 9 times 2, which is 18. And so this overall is 67 minus 42 root 2. So a couple more examples. We're just going to do a bunch of examples today. Root 3 minus root 2 minus 1 over root 3 plus root 2. Here we secretly use something like a minus b times a plus b is equal to a squared minus b squared. So this becomes root 3 minus root 2, root 3 plus root 2 minus 1, all over root 3 plus root 2, and equals, using this, 3 minus 2 minus 1, all over root 3 plus root 2, and that's actually 0. There you go. You can generalize to any values. Again, we always assume that a and b is non-negative. Root a minus root b minus 1 over root a plus root b is equal to root a minus root b, root a plus root b, minus 1 over the denominator, and that's a minus b minus 1 over root a plus root b. So just as a warning, the signs do matter. So suppose you said that 49 is minus 7 times minus 7. This becomes quotation marks. Not equal. But of course, this step was wrong, right? This step was wrong. Hopefully you can see why this is wrong. If you can't, take another look. By definition, root of 49 is the positive square root, so that 7 is not negative. This is different to saying there are two solutions to the equation x squared equals 49. These are different statements. Okay, and the last thing we covered are fractional powers. We wonder, what is a over to the power of p by q, or maybe simpler, a to the minus k? For instance, 7 to the 2/3 or 3 to the minus 9, just some numbers. In general, a to the u to the v is equal to a to the uv, and so a to the p by q is equal to a to the p to the 1 over q. So this is a power, and this is a fractional power. It suffices to understand a to the 1 over q, because we understand a to the p. Sorry, fire alarm. A to the 1 over q satisfies and so it's the inverse power to taking to the qth power. And number 2, similar to a to the minus k, is the inverse power to a to the k. We're done.